How do semi-magic squares differ from magic squares? Have you ever wondered how some number patterns can be almost perfect but still miss the mark? Today, we will look at semi-magic squares and how they differ from magic squares. A magic square is a special arrangement of numbers in a square grid. In a magic square, every row, every column, and both main diagonals add up to the same number, known as the magic constant. This balance is what makes magic squares so fascinating. Now let's talk about semi-magic squares. These squares are similar but not quite the same. In a semi-magic square, the sums of the numbers in every row and every column equal the magic constant. However, the main diagonals do not necessarily add up to this magic constant. This is the key difference that sets them apart from true magic squares. For example, imagine a semi-magic square of order 4. Each row and each column might sum to 34, but the sums of the two main diagonals could be 19 and 49. This shows that while the rows and columns maintain the magic constant, the diagonals do not. This distinction means that semi-magic squares are a broader category. They include squares that are almost magic but lack the diagonal property. While they may be seen as less perfect, they still reveal interesting patterns in numbers. From a number patterns perspective, semi-magic squares highlight how close structures can be to full magic squares. The role of the diagonals is essential in achieving the symmetry and balance that defines magic squares. Studying semi-magic squares can also be a fun way to engage with number puzzles. They serve as an accessible entry point into the world of magic squares and their many variations. In practical terms, these squares can be useful in mathematical recreations and puzzle design. They help us understand how changing one condition can affect the overall harmony of a number arrangement. So, while magic squares are the gold standard of numerical balance, semi-magic squares still hold their own charm. They invite us to appreciate the beauty of numbers and the patterns they create, even if they do not meet every requirement.